5 minutes. That's the time to quarry a 3-ton stone block, transport it for a kilometer, and set it with a precision that shames modern engineering. 1 block every 5 minutes. 10 hours a day for 20 years straight. How? Forget aliens, forget magic. The answer is far more impressive. The Great Pyramid wasn't a construction project. It was the largest assembly line in human history. And today, we're going to dismantle the engineering system and the brutal logistics that made the impossible possible.
Every great process begins with a master plan. At Giza, the project manager was Hemiunu, the pharaoh's vizier. He wasn't just an architect, he was a chief operating officer. His task, manage a complex supply chain. The product, the pyramid, required 3 main raw materials. First, the structural limestone, about 2 million blocks, quarried locally right at the Giza site. Second, the Aswan granite, used for the inner chambers. This was the heavy logistical challenge, moved 800 kilometers. Third, the white limestone from Tura. This was the polished outer casing, the skin that would make the pyramid shine.
The assembly line began here, at the quarry. But how do you cut granite, one of the hardest stones in the world, using only copper and wood? The answer? Process and patience. For the softer limestone, they used simple copper chisels. But for the hard granite, the process was brutal. They dug channels by pounding the stone with dolerite balls. Next, they inserted wooden wedges into these channels and soaked them with water. The wood would expand, and physics did the rest, splitting the massive block from the bedrock. Each block was cut with precision and, crucially, marked. Archaeologists have found markings from work teams, indicating a managed system of crews and sectors, much like a modern factory. Quality control began at the source.
Now, the biggest logistical challenge, moving millions of tons of stone. The solution for the long-distance granite was the Nile River. The Nile wasn't just a river, it was a seasonal transport system. The entire project was planned around the annual flood. For 3 months a year, the Nile overflowed, allowing their heavy barges to sail over the floodplains and arrive almost at the base of the Giza Plateau. An artificial harbor was built specifically to receive this raw material at the construction site. But what about on land? How do you move a 2.5-ton block from the port to the pyramid base? The answer is an icon of process engineering: the sled. But there was a system hack. Physicists discovered that the Egyptians likely wet the sand in front of the sled. The right amount of water hardens the sand and reduces friction by half. They didn't need more force, they needed less friction. They optimized the process.
Okay, the blocks are on the factory floor. Now, how to go up 146 meters? The popular idea of one giant straight ramp is logistically unfeasible. Analysis shows it would have required more material and labor than the pyramid itself. It's an inefficient process. So, what was the real system? The evidence points to a more efficient solution: a system of ramps. Likely an external ramp that zigzagged up the face for the lower levels, and for the upper levels, a brilliant process hack: an internal spiral ramp. This system allowed them to build from the inside out, using the pyramid itself as the foundation for the ramp. At the corners, they left small openings. Here, teams used woody levers to pivot the block 90 degrees, onto the next section of the ramp. It was a continuous vertical assembly line, moving blocks upward 24/7.
Historians are still debating the internal ramp theory. Does it make sense to you, or do you think the external ramp was the real solution? Let me know your theory in the comments.
But the most sophisticated part of this assembly line wasn't the ramp or the sled. It was the human system. A factory this large needs a workforce. We're talking 20,000 to 30,000 skilled workers rotating in shifts. Forget the Hollywood idea of slaves. The evidence points to the exact opposite. Archaeologists discovered the workers' village just south of the pyramid. This wasn't a camp, it was a city. It had bakeries capable of producing thousands of loaves of bread per day. It had breweries. It had medical facilities. Analysis of worker bones showed they ate prime beef, mutton, and fish. They were well fed and received medical care. Healed fractures show that workers who got injured on the job site were cared for, not discarded. This was a logistical feat in itself. Managing the food, water, and housing for a city of 30,000 people was a process as complex as building the pyramid. They were organized into crews and divisions with proud names like the Friends of Khufu. This was a skilled, motivated, and most importantly, managed labor force.
So what is the Great Pyramid? It's not a monument to magic or aliens. It's a monument to process. It is the physical result of an optimized system, a high-efficiency assembly line designed and managed by human beings. It's a testament to project management, logistical planning, process optimization, and human resource management. The final product isn't just a tomb made of 6 million tons of stone. The product is a perfect system, and that is the most powerful engineering of all.
We have just dismantled the Great Pyramid. If you want to see the engineering behind the Roman Colosseum or the Great Wall of China next, hit the like button so I know which blueprint to analyze.